Assalamu alaikum. I welcome all of you to the course on advanced mass spectrometry. As we have started electron ionization, mass spectrometry, hard technique. So today we will be discussing about the ion source of electron ionization. As this ionization ion source makes this technique a harder one. So we will discuss it in great detail, but before understanding the electron ionization mass source, we have to go through some preliminary pre-material which will be very much helpful for students to understand that how the mass spectrum, how the ionization source operate, and what is going on inside it. So let me start explaining it with some sort of analogy. First of all, as I mentioned that in mass spectrometry, what happens, the basic principle is to detect the mass of analyte. Okay, so here first previously we studied the inlet source, that how to feed, where we studied that how to feed the analyte to the mass spectrometer, and now after that we will be studying the ionization source. So that was like inlet source, and this is ionization source. Okay, inlet source or ionization source, that how ions are generated. Okay, so again I am telling you that the mass spectrometry, electron ionization mass spectrometry, is a hard technique. So I will give a touch to some examples in order to understand that what's happened inside the ionization source. That will be quite helpful. Let's suppose we have a methane molecule, CH4 molecule, and we want to detect its mass. Okay, so how we can do it? So how the mass spectrometry does it, or the electron ionization does it? So again I am giving you some sort of analogy. Here you have this thing, and it becomes something like CH4 plus or radical, and then that thing goes to the analyzer, and after analyzer it goes to the detector. And what is its weight? 12 and 4, 16. Okay, so you get a mass spectrum or a peak at 16 m by m or z. Okay, what's happening here is the ionization source, is the work of ionization source. So again, let's say that this methane molecule comes here and it wants to pass here, pass from this pathway, and here is a gun loaded with electrons, and it just hit or bombard the methane molecule. Okay, and it somehow extract the electron out of it, and it is like, it become like this CH4, and then after that this CH4 is pushed and to the analyzer, and somehow it reached the detector, and we got the spectrum. Okay, so some questions will arise, that what is this radical, where it came from, how the positive charge comes. So again, as you know that carbon, we need to go to the very basic hybridization, that the carbon has valence electrons, 4 valence electrons. It can form 4 bonds, okay, with hydrogens in methane. But let's suppose, as you know that there are 2 electrons which are not taking part in the hybridization. They are the 1s electrons. They are also present. Suppose they are present in the molecule. They are present inside the carbon atom. If we look to the molecule or the structure according to the valence bond theory or theory of hybridization, so that electrons will be not involved in hybridization. Okay, And if one of this electron is ejected out from the carbon atom, what will happen? As you know that if like this, if this is a carbon atom, okay, these are the two electrons on one s electron, suppose, and another electron gun hit this electron out, and you will have this thing, and I have to write a positive charge on this, because first the molecule of the methane was neutral, okay, and now it lost one electron because a gun was there and it hit one electron and the electron was extracted. So one electron come and two electron goes out, so the molecule becomes some sort of positive charge thing. Now this positive charge thing, we don't know what happens to it, but it somehow goes to the detector and is detected and its mass is given. Okay, but it's not that simple. So the before ionization source, why I am telling about these things, because these will be the questions which will come in your mind when we finish this ionization source. Okay, suppose this methane molecule, one methane molecule has the core electrons were ejected out of it. Now it's another methane molecule, okay, and one was detected. And now it's another molecule, because in the gas molecule there are thousands of molecules. In one molecule only the core electrons were out, and what happens? There was no change in the mass of the molecule and it was detected. Let's suppose somehow this molecule, as you know that this bond is composed of two electrons, okay? One electron is this, and the other electron is this. Now let's see that suppose that the gun hit this electron out, okay, and this electron goes out. One electron comes and two electrons goes out. This electron is out, okay, because it was hit by an atom. It's never hit directly by an atom, but for understanding, let's suppose it was hit, and you get another molecule like this, CH3. This thing is, I have written positive because one electron was lost and one electron of the bond. And you know that the bond becomes weak. As you know that normally the molecules vibrates, okay? So what if this bond vibrates? When this vibrates, this bond will never come back and the molecule will break. But as the molecule break, what will happen? A CH3 plus charge thing will be produced, okay, and a radical will be also produced along with this, but this radical is not detected and the positive CH3 is detected. Again, we don't know that how it is detected, because we'll understand it when we study the ionization source, okay, or the mass spectrometer. But right now you should think that only the things with a positive charge on it, whether it is a full positive charge like this or whether it was CH4 plus dot, those things will go to the detector, and the radicals, because this radical is neutral, it will never go to the radical. Though this thing is again a radical, but this radical has some positive charge. Anything which has a charge will be detected, and anything which doesn't have any charge or neutral radical will be lost. How it will be lost? We will see it in the mass spectrometer or the design of the mass spectrometer, that why it is lost, okay? Suppose you have, this is just a background, we will study each thing, each fragmentation, but this is a background to that you may understand some questions, okay? Suppose if you have big molecule like CH3 and CH3, the mass spectrometry is the electron ionization is a hard technique, so it is now this molecule has several bonds in it, okay, so it is less possible that the whole molecule will go to the detector, okay, so this molecule will there are a lot of bonds in these molecules. CH2H, this bond this bond can be hit, this bond can be hit, 3 CH bonds here, 3 CH bond here, any bond can be hit, and as the bond is hit, the molecule will broke on that place, and a radical will be produced. Suppose the molecule is hit here, so what will you get? You will get CH3. Suppose this plus come here and HCH3 this come here, so you will get a CH3 plus and a CH3 radical. So you will, what will you detect? You will detect a 15, because positive is detected and the radical is lost. Okay, but one thing which I have to say, that if when the molecule size become bigger, then the whole molecule, the detection of the whole molecule is not possible in mass spectrometry. And how it is not possible, you will again understand it in the ionization, subsequent ionization source, when we will be discussing that. Okay, so right now what we understand that in mass spectrometry, electron ionization, there is some sort of a gun of electron which hit the molecules, and it extract the electron out of it, and the molecule become unstabilized, or it just breaks and is detected. Okay, some fraction of it is detected, and the positive fraction is detected, and the neutral fraction is lost. But we really don't know that why a positive is detected, where the electrons are coming, and how they're hit. So let me give you a very simple or basic electron source model, so you will understand that. Okay, now I am giving you, I am just writing a very basic model of ionization source, just because when you understand this basic model, then you will be able to understand the real or the advanced model of electron ionization. Okay, so you need to focus on this thing. If you understand the basic thing, you will be able to understand the real or the more complex ionization source. So it is just a small image type of thing, or you can say it's a very basic model. Okay, so I have tried this model. Before that, you need to understand this model, and as you understand this model, you will be able to understand the advanced models, and some other questions you will be able to answer. Okay, that why this energy, why this thing, why that thing, why. Let's see, let me draw it. Okay, this is very basic model, and in almost any mass spectrometry book you will find this thing. Okay, okay, now that's how they built the gun, electron gun, or how the ionization take place. Okay, so let me explain some of the parts of this thing. It's again, I am recalling you or reiterating this thing, that this model is the very simple one. I am just trying to make you understand this sketch, because it will help you to understand the advanced model of the mass spectrometry. Okay, so let's see. This thing is called as the filament. Okay, filament. This thing is called as the trap. This thing is called as the repulsion plate, or repulsive plate, or pushing plate, you can say it. Okay, so this thing will push something. Okay, this thing will either attract something or accelerate something. How and how they will be doing it, yeah, I'll explain it in the advanced model, and I've tried to explain it right here without any figures or digits. I will just explain it in pictorial form of way, and in the advanced model we will explain it in digits, figures, etc. It will then be helpful for you people to understand. Now the electrons comes here to this thing, okay, and M stands for magnet. Why a magnet is here? What is this? What are those negative charges? 1 negative, 2 negative, 3 negative. What does those means? What the positive charge mean? And this, I told you that this is a filament. The filament is made up of what? It's a tungsten filament, okay? So the electrons moves from the tungsten filament and it comes to the trap. Now we really don't know why would the electron come out from here and it would come here, okay? Because in advanced model you will see that how. So suppose for now, if a metal, if you want to extract electron out of a metal, what can you do? The easiest way is to heat the metal to incandescence. What is incandescence? Incandescence means that the metal should glow. When you heat it so much, what would happen? It will throw its electron out. And suppose electrons are negative charge and you have some positive thing, you have positive charge thing is placed here, so the electron will quickly come here, okay? So the electron should come from here to here. Because this thing is glowing, the filament is glowing, it is emitting electron. Because what is emitting? It's throwing electron, but it's coming here. This thing is positive. But again, you may have some question that this thing is negative, again positive. Why the electron are not moving this? In advanced model with digit figures and everything, I will explain that, okay? But right now you should think that why the electrons come from here to here, okay? So suppose, let's assume for right now that these electrons have 70 electron volt of energy. These electrons are flowing with 70 electron volt of energy. And here, let's say we have connected, what is this? This is the inlet source. Inlet source. Inlet, I for inlet and for source, okay? Now suppose you have a methane molecule, a large number of methane molecules you have with you in the inlet source, okay? So suppose they are coming here. How would they come? Again, here is another thing, okay? The pressure in the pressure here is very much less. It is 10 raised to the power minus 6 torrs. Okay, so what is the benefit of the less pressure? The less pressure, when the pressure is less here and the pressure is more here, it will suck the electron, the gas from here to here. Okay, it will automatically, spontaneously move from the higher concentration towards the lower concentration, because the pressure here is more, methane pressure here is less. The pressure here is less, and here the methane gas has more pressure. It doesn't have any methane, it is vacuum, under vacuum, high vacuum, so the electron will flow, the molecule will flow. So right now, when the gas methane come here, it will collide with this thing. It never collides, it will be clear in the model, okay, in the original model. But suppose it collides with the model or the electrons, and the electrons moves out of it, okay. So let's a small methane molecule come here and it is collided, electron bombarded it, okay, and it will become a positive radical. That's why I draw the positive radical type of a species. Suppose the methane molecule came here and some electron gun, this is the electron gun, okay, it hit and extracted the electron out of it, and now the methane become a positive radical. So let's say it's our methane, okay. So what happens? It is hit by a gun. This is the gun. Suppose this is the methane molecule and I am writing it here, okay. Now the 70 electron volt electrons fall on it and removes suppose one of the 1s electron from the methane, okay. If one of the 1s electron is removed from the methane, this is the 70 electron volt, and it is removed, now you have a species like this. Okay, this species is produced. Suppose we really don't know, but one thing we know right now, that something which is either positive, has some charge on it, positive charge, it is going to be detected. So this go to the analyzer, and after that it goes to the detector, and it is detected, and mass spectrometer will give you a mass of 16. Okay, m by z. Okay, this is m by z. So what we have studied today, we have just studied a preliminary model, a very basic model of the ionization source, electron ionization source. Here is the inlet source from where the molecule it is at higher pressure, and suppose you have methane come here because here is low pressure, 10 raised to the power minus 6 torrs, and so the methane here comes, and as it comes in contact with the electrons, so because the electron is moving very fast, it removes one electron from it, and it became a radical, okay, positive radical, or sometimes it is called as radical cation. Okay, now this radical cation, this thing is positive, this thing is positive. As you know that positive repel each other. It will again solve our one question, that the gas here was not repelled by those things, but as it become positive charge, it is repelled by this plate. Okay, once it has become positive repel each other, and it pushes it to the analyzers and then to the detector, and it is detected. So this is the very preliminary model, and I am going to explain, we will be discussing a little more advanced model of the electron ionization source in the next video. Okay, thank you very much.